Hey everybody, David the AI Guide here. Welcome to another episode. Thanks so much for tuning in. I really appreciate it. So, cool article, lots of breakthroughs in robotics, and we're going to talk about that in just a second. But first, be sure to follow us on Facebook, Instagram, and Twitter. Also, click the link below, get your free resource to learn more about AI. The resource is free, everything in the resource is free, and if you get the resource, you'll get the opportunity to participate in my beta course. And that would be absolutely free while it's in beta. So thanks so much for tuning in, and check out my book on Amazon, The Beginner's Guide to AI, History of AI and Current Impact on 10 Different Industries. It's short, about 2 hours to read the whole book. And it's cheap, so check it out. Thanks a lot. So, robotics. Very, very cool article today on the NASA website. And this article is really going to give you a glimpse of the future. So, this article is about NASA partnering with GM, General Motors, to develop a robot back about 15 years ago that was sent to the space station in 2011. So that's 11 years ago. And at the time this was done, this was a true breakthrough because this robot was far ahead of Boston Dynamics and other people who were in robotics back at that time. But that is not the focus of this article. That's the background. The focus is that there's a guy who worked at NASA Johnson Space Center where NASA helped build this robot. He worked there for 14 years, and then he started a company called Aquanauts. So this is robotics for the ocean. And we've talked about a couple of things about the ocean before. First of all, only about 5% of the ocean floor has been mapped so far, so that's near zero. And he talks later in this article, we'll check this out, about how much opportunity there is with regard to the ocean. But specifically with robotics, the guy who founded the company, Nick Radford, who used to work at NASA, says, NASA taught us to put together robust software. What kind of software? AI, of course, AI software with a capable hardware system and deploy it in a remote setting. So he has hired more than 20 engineers, a total of 80 people to work at this company, Nauticus, right now. And whether a robot is working in space or on the seafloor, the operator is far away, right? And you're trying to control the movements of the robot without a direct connection, typically, and there's a lot of lag, so the robot pretty much has to know what to do to keep itself safe because there's too much time between commands. This is exactly the case with Curiosity and Perseverance on Mars. Too much transit time of signal, and so they have to be partially self-reliant, i.e. AI self-driving. For Robonaut 2, this meant that Johnson engineers had to develop joints for the robot and vision systems. We've talked about that a million times. Sensors, we've talked about that for force and infrared. And of course, AI software to recognize images and control algorithms and direct it. Robonaut 2 was the robot that was built for the space station and launched there in 2011. Now, unlike a robot in space, deep sea robots can be connected to operators with a cable from a ship on the surface, but here's the problem with that, and I couldn't believe this. To keep the ship there, it cost $100,000 a day to run the robot. So that's not really feasible, is it? So Nauticus, this company that was founded by the former NASA guy, Nick Radford, is eliminating that cord by enabling its robots to work with minimal supervision from a control center on a distant shore. And they go on to describe the robot, which I'm not going to do because it's not important to the point I'm trying to make here. But they did return to NASA to test the robot in the huge pool that they use to train astronauts for space. And this robot is designed to be very versatile with a couple of arms, and it can configure itself differently. And there's a lot of uses for this thing. For example, undersea oil and gas wells need regular maintenance and inspection, and these robots can do it. And check this out. The fastest growing ocean industry is wind power. 25,000 new offshore turbines planned by 2030 in the next 8 years. 25,000 of them. All of those also need inspections. And they're also using these to monitor wild fish populations, which are in sharp decline. And then other uses, port management, maintaining undersea communication cables, which is how we communicate with Europe, for example, and defense, of course, and undersea mining. They can use this for undersea mining. So by early this year, 2022, Nauticus had produced 2 of the Aquanauts and planned to build 20 more in the next 3 years. And they're going to lease them out rather than sell them. But here is the tripping thing that I wanted to make, which is the point I wanted to make. So check this out. Think of the future. Robots are doing all undersea maintenance and inspection. Robots are all doing all space maintenance and inspection. And they specifically talk about how a robot is going to maintain the new gateway that will be around the moon. But that's extreme environments. We know, because we've talked about it a lot, that robots are very soon going to be everywhere. And these capabilities are just as suitable for land, for dangerous occupations like fighting fires or environmental hazards, or going and inspecting production equipment that's dangerous. GM participated in the original robot development to perfect their production robots, which we've already talked about as well, to take them to the next generation. So people are working very hard on robots. These robots and the ones that are coming are all heavily dependent on artificial intelligence. Why? They need to be able to make decisions for themselves, watch out for obstacles, complete a task, and then go to the next task, like the home robots, vacuuming, then unloading your dishwasher. So this is just one company, Boston Dynamics, the major car companies that are developing the home robots. The world is going to change very, very quickly, very, very soon. We're talking medium term, which is 3 to 5 years, robots everywhere. Why? Because they're flexible, they don't get hurt, they can do dangerous tasks, and they're cheaper. That's why. So thanks so much for tuning in. We'll see you next time. Click the link below, get your free AI resource. Also, check out my book on Amazon, and we'll see you on Sunday for the next video. Take care. Bye.